Many global policy targets are now built on a singular vision, a world where electric drivetrains have entirely replaced fossil fuels. To reach that goal, the automotive industry is engaging in a massive, coordinated scale-up. Existing factories are being gutted and rebuilt to manufacture millions of battery-powered cars every year. This rapid transition is fueled by a specific neurological mechanism. When we anticipate a major technological shift, the brain produces a reward prediction error, a dopamine spike that occurs when a future expectation feels significantly better than our current reality. When millions of investors and policymakers experience this spike simultaneously, it creates a powerful collective momentum. This optimism makes 2030 targets feel like a certainty, often masking the physical constraints of the planet itself. But a global market built on expectation eventually has to reconcile with physical inventory. That inventory is lithium. It is the specific, non-negotiable material required to build the high-density batteries that make long-range EVs possible. While the Earth's crust contains vast amounts of the mineral, only a fraction exists in a state that we can actually extract and refine for industrial use. This creates a dangerous gap in our planning. We have mistaken total geological abundance for immediate market availability. Think of the Earth's total lithium supply as a vast ocean of undrinkable water. The portion we can actually turn into a battery is roughly equivalent to 1 bottle of clean drinking water. This limit is known as the geochemical ceiling. It is the hard geological wall where the rising curve of consumer demand meets the reality of the Earth's crust. Getting to that supply is a slow, difficult process. In South America, it requires pumping subterranean brine into massive pools and letting the sun evaporate the liquid for months or years at a time. In other regions, it means hard rock mining. This involves blasting through thousands of tons of rock and processing the ore through heavy industrial facilities to find a few pounds of usable mineral. This isn't a software challenge that can be solved with a more efficient algorithm. It is a brute force problem of geology and physics. Mining also operates on a different timeline than consumer electronics. It takes an average of 8 to 10 years to discover, permit, and build a single new lithium mine. This chart shows the disconnect. EV demand scales exponentially in months, while physical lithium supply crawls, lagging a decade behind. It's a kitchen with an exploding customer line, but a 10-year wait for a new stove. The result? A persistent structural shortage. Because of this delay, current production targets for the next few years are essentially locked in by the mines we started building a decade ago. Governments have set 2030 as the year they intend to see these roads dominated by electric vehicles. But a mine that breaks ground today won't reach full production until at least 2034. The timelines of law and geology are out of sync. When an expected reward fails to arrive, the dopamine signal that drove early investment drops sharply. This creates a systemic dip where the high of the green revolution hits the reality of the material shortage. This shift leads to manufacturing delays, skyrocketing mineral prices, and a sudden, painful correction for those who assumed the transition would be frictionless. Investors are now finding themselves caught in these long supply cycles. When billions are committed to factories that lack raw materials, the financial risk becomes a core part of the transition. Much of our current market logic assumes that innovation is purely digital and infinitely scalable. We act as though we can innovate around a lack of physical matter. This leaves the industry with 3 paths. Lithium prices could rise until EVs are only for the wealthy, the adoption rate could drop, or we could pivot to unproven battery chemistries. The success of the EV revolution will not be decided by how many cars we want to build. It will be decided by the physical reality of the dirt beneath our feet.